Today we shall discuss the chapter on complex numbers and quadratic equations. What is say number 2? I to the power 9 plus I to the power 19. Why I have taken I to the power 4? As because you know that I to the power 4 equal to 1. So always take as part of I to the power 4. So I to the power 4 whole square into I plus I to the power 4 whole to the power 4 into I cube. Now put these values, then you will get the result. Similarly, say number 6 problem, 1 minus I whole to the power 4. We can write 1 minus I whole square, then square. So a square minus twice ab plus b square. As because I square equal to minus 1, so cancel this two factor. Minus 2i whole square, that is 4i square, means minus 4. We can write in this form a plus ib, that means minus 4 plus I into 0. Number 7 problem is, take minus 1, this a plus minus of a plus ib whole cube. Put in the formula a cube plus c square b plus cab square plus b cube. Find the multiplicative inverse of the following complex numbers. I have taken this root 5 plus ci. Z inverse means 1 by 2 root 5 plus ci. If I have a complex number in this form, 1 by a plus ib, you have to multiply numerator and denominator by a minus ib. If I have the denominator is a minus ib, then you have to multiply. If you have like this 1 by a minus ib, you have to multiply numerator and denominator by a plus ib. In this way. Now, what do you mean by the modulus of a complex number? If you have a complex number z equal to a plus ib, modulus of a complex number is defined by mod z equal to root over positive square root of real part square plus imaginary part square. And these are the properties of the modulus I have given here. Z into z bar means conjugate of a complex number. Suppose we have a complex number z equal to a plus ib. What is the conjugate of a complex number? Z bar. This will be equal to the sign of the imaginary part will change, that is a minus ib. And these are the properties of the modulus. This is the conjugate, what I have discussed, conjugate of the complex number. It is denoted by z bar. So what is the conjugate of this? Minus a minus bar. The conjugate of z is a minus ib. Just sign of the imaginary part will be changed. And conjugate of conjugate is the number itself. And what do you mean by z plus z bar? Suppose we have z equal to a plus ib. Then z bar, what is our conjugate? A minus ib. So if you add this two, what will be? Z plus z bar? Z plus z bar, this will be equal to twice a only. Twice a. And what is our z minus z bar? Is equal to 2ib. If z equal to z bar, then if z is purely real, then z must be equal to z bar. These are the properties. We have taken the modulus of say 5 plus I, root over of real part square plus imaginary part is 1 square, that is mod of 3 minus 4I means root over of 3 square plus minus 4 whole square, that is our 5. Now, I have taken another example. If x minus iy is equal to root over a minus ib by c minus id, prove that this. First to remove the square root, you square both sides. So x minus iy whole square equal to this. Just like this, you will get this part. Now, equate the real and imaginary part both sides. Real part of the left side is x square minus y square, and here the real part is c plus bd by c square plus d square. So equate this to an imaginary part minus twice xy equal to imaginary part is our ad minus bc by c square plus d square. Next, a plus b whole square means a minus b whole square plus 4ab. So put here after simplification, that will give the result. Next problem is, you are given two complex numbers z1 and z2. Find modulus of z1 plus z2 plus 1, z1 minus z2 plus 1. First put the values of z1 and z2. z1 plus z1 by z2, we know that in case of modulus we know that z1 by z2 is equal to, for two complex numbers we have z1 by z2 modulus must be equal to mod z1 by mod of z2. So mod z1 means mod of this part, mod of this part. Put this value, take the modulus. Take the modulus. Now, number 3 is a plus ib equal to x plus I whole square by 2x square plus 1, then a square plus b square equal to this. You have to prove it. Left hand side is of the form a plus ib. So first you put the right hand side in the form a plus ib. So simplify this. This is a plus ib. Now we equate real and imaginary part both sides. Left hand side real part is our a. A is equal to x square minus 1 by 2x square plus 1. Imaginary part is our b equal to twice x by this. Now a square plus b square, you simplify, that will give the result. Next we are discussing another problem. Find the real numbers x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 minus 24i. First, we know that what is the conjugate of minus 6 minus 24i. Suppose we have a complex number. What is the conjugate of this? If you have the complex number, z equal to this. We have just discussed the sign of the imaginary part will change. So this is the conjugate of this complex number. Now, right here first, conjugate of this complex number is minus 6 plus 24i, and here you multiply both sides and take the real part and imaginary part separately. Now we equate both sides, real and imaginary part, that will give two equations. Solving this, we will get x and y. Similarly, for the second problem, first we simplify a plus b whole cube and then equate real and imaginary part both sides. Here the real part is our u, so u equal to this part, imaginary part equal to this. So now you want u by x, divide by x, and v by y, then add, that will give the result. If 1 plus I by 1 minus I equal to whole to the power n equal to 1, least positive integral value of n you have to find. First, 1 plus I by 1 minus I, put in the form a plus ib. So you have to rationalize this. You have to multiply numerator denominator by 1 plus I. After simplification, this will give only I. So left hand side equal 1 plus I by 1 minus I whole to the power n. equal to 1 implies I to the power n equal to 1. Now what is the least positive integral values of n? So first if you put n equal to 1, then this result will be left hand side will be equal to I. This is not equal to 1. N equal to 2, this is minus 1. If n equal to 3, left hand side is our I cube means minus I. If n equal to 4, then I to the power 4 equal to 1 equal to right hand side. So what is the least positive integral value? 4. Argand plane. How to represent a complex number in the Argand plane? You are taking this as the origin and x-axis as the real axis and y-axis as the imaginary axis. Any point, say a0 on the x-axis represented by a plus I into 0, and the imaginary axis that is on y-axis, it will be represented by 0 plus ib. So on y-axis, this point will be 0b, and on the x-axis the point will be a0. For example, the complex numbers 2 plus 5i minus 2 plus 4i, the ordered pair will be 2 5 minus 2 4, like this. Here minus 5 minus 3, 1 minus 2i means 1 minus 2, like this. The points are in this form. Next, so if a complex number is z equal to a plus ib, representation is the point AB. What is the distance from the origin? Distance between 2 points 0 0 and AB, root over a square plus b square. This is the distance between the points AB and the origin. Conjugate of the complex numbers, that is a minus ib. What we will represent? A minus ib means A minus b. Ordered pair will be a minus b, and representation is like this: a minus b.